to echo all the speakers before me and say thank you very much to Livia for the invitation to be here. I saw many of you 2 years ago in Stresa in Italy, and it's great to see you here in Toronto, which is just an hour away from my old stomping grounds out in Kitchener-Waterloo. So for me, it's a homecoming, and I'm very happy to be here. So I'm going to talk to you from an industry perspective, yes, the big bad industry, what we are striving to do and some of the barriers that we face. I learned a lot by going into industry and finding out that the challenges we face are more difficult than I anticipated. And making food is a complicated business, and the more I learn about it and the more I try to apply nutrition, I think the better we can work together as scientists within industry and academia, maybe we can actually make some advances together. So I'm going to talk about slowly digestible carbs or slowly available glucose, and I want to thank my previous speakers for introducing these terms because it's really the slowly digestible portion of carbohydrate that lowers the GI. So that's a target in industry, and that's something we're working on. Let me find my clicker. Okay. So that's, yeah, I have animated slides, which sometimes I forget I animate my slides. So what does this have to do with glycemic index? Because we know it's the slowly available that really reduces glycemic index. So from a food industry perspective, we are challenged with trying to formulate high carbohydrate foods that consumers want. And as a supplier, I am particularly challenged to provide ingredients to the consumer goods companies that help them in their formulation goals. So all of the big companies here, the big packaged foods, have certain programs and they're trying to hit their targets, but they need ingredients to make these foods, and they come to me looking for all the answers. So in industry, we are focusing on high glycemic foods and trying to reformulate, reimagine these kinds of foods to lower their glycemic impact. And what are those foods in particular? These are really the candidate foods when we're talking about lowering glycemic index. These are foods we're not going to eliminate from the diet. People want to eat scones, they want to eat bread, and as we heard in Germany, bread is very important, but it still does have a relatively high GI. And people are going to want to keep eating them. Cereals also, a lot are very high GI. Bagels, pasta, you can read the list. These are all the types of baked products. So how can we change these baked products? That's the question. How can we reformulate? So in my opinion, we're going to have to go after the worst offenders, and that's the first thing you're going to do when you have a high glycemic product, is look at why is it high glycemic. Well, it's the finely ground flours, it's the sugars, especially the maltodextrin, which is very high glycemic, and there are some oligosaccharides too that have been used as bulking agents, sweeteners that give form to food that are also very high glycemic. But we can't replace everything with types of carbohydrates that are inherently low glycemic. You need intact grains that are minimally processed. You know, the kibble bread, even that was a moderate GI. So we can't keep making all of these foods by using whole lentils in them. You know, we have to find solutions that are going to work in the foods. So that's what I think about, is how do I come up with ingredients that actually work in all of these applications and people will want to eat them. So we can't have everything whole, you know, whole meal, whole grain, and you wouldn't want that either. I think only the most zealous person would want to eat like whole lentils every day, never have a scone again as long as they live. So that's the challenge. And it also has to apply to one food. In industry, we're formulating a food. We're not working on someone's whole diet. I wish I could. It'd make it a lot easier. But we're working on a food, and that food has to have a lower glycemic impact. And it needs to reflect how the food is eaten. So you've heard from Alfred Aziz in terms of the substantiation for a food. We consider how the consumer eats it. That's how we're going to test the glycemic impact. So what approaches can we use in all that long list of the high glycemic culprits that we all eat? Well, first, as my title alluded to, you have to do this with a slowly available glucose. Okay? A glucose that's released slowly will give you a lower glycemic impact compared to the rapidly available glucose that we in the food industry are very capable of producing. So we have all sorts of high glycemic flours and sweeteners. How do we make them slow? So this is just a little chart showing you hypothetical food. It could be a scone. You'll see it has a lot of rapidly available carbohydrate. This could be mostly flour. Then you have a little bit inherently slow that's in that flour, maybe a little that's resistant, which would say it's fiber. You've got just a little protein left in the flour, and maybe some fat. So this is really the kind of bad guy that I'm thinking about, is how do we get this product to be lower glycemic? This is what you need to do. You need to take half of that rag and turn it into slowly available glucose. This is easier said than done. These pie charts are very easy to make. Making this ingredient or this formulation is very, very difficult. Now you want to know how much replacement do you need, and a good place to look is in claims. So if you look at claims that have been granted, this is an EFSA claim for slowly available carbohydrate, they will show you all the studies and how much replacement was needed to get that effect. So this is based on all the work that was done by Mondelez and Kraft on the Belvita line of crackers, where they compared their type of biscuit to extruded cereals, which are very high glycemic, but they have very similar ingredients. And when you look through their studies, you see how much digestible starch was in the food. This is showing the biscuit versus the cereal. Then it shows you how much of it was SDC or SAG, whatever acronym you like better, in that biscuit. Okay? And when you look at the results for blood sugar, you see when you get down to 35%, it's no longer significant. It's only in these studies that had at least 40% of the available carbs as slowly available carbs that you get an impact on blood sugar. So that's a very good learning to, and that's what I pay attention to, is how much do I have to get into a formulation to have an effect on blood sugar? So if you're doing this with the flour and you need to have 40% of the food as slowly available, how much of the flour needs to be slowly available? Or are you completely substituting the flour? Are you changing the flour? How are you getting it to be slowly available? So what approaches can you use to do that? How can we formulate these foods, still enjoy them, but have a lower impact on blood sugar? And we've seen this also. This concept was introduced in the time course using an English assay to define what is slowly available. So in the first 2 hours, this is what we deem to be digestible. The first 20 minutes is rapid. Everything in between 20 minutes and 2 hours is deemed to be slowly available carbohydrate. The rest is considered to be resistant and will assay as fiber, depending on what type of carbohydrate it is. So this is what we use. We do a lot of English assay work in our lab, and we test all sorts of different ingredients and look at the profiles. And I can tell you, very few of them have 40% SAG. We've tried all sorts of modifications, chemical modifications, heat steeping, all sorts of different approaches, and you just can't get 40% SAG. Belvita, the claim that EFSA granted, was based on a par baking procedure. It's not based on an ingredient. So I'm still trying to come up with an ingredient. So far, I don't have one to sell you today. I wish I did. So it's actually not that easy. And I think a lot of you working on GI might not realize that. So in industry, we're looking for the technical. We're trying. We want to deliver this. But it's just not that easy to just change all of these foods, and they're all going to become lower glycemic. It will no longer be a scone if I put in 10 grams of glucomannan. Sorry, Dr. Vuxen. But you can't make these products with the type of low glycemic products that we have, the ingredients that we have. Okay, it still has to be a viable product. So there are very few options that are SAG, and that's what I want you to understand today. It's not that food industry doesn't want to do it, it's that I don't know how to make a scone that's lower glycemic without it no longer being a scone. Okay, you can try whole grains of bits. We try all sorts of things like that, but the more you put in, the worse it gets. The taste gets bad, and it's just, I've tried 2 grams of guar, and we can't get that through our sensory panels. It's just, and I taste them like, oh, it's raspy, it sticks to my teeth. I would not eat this more than once either. Most of the ingredients that are useful for reducing the glycemic response only have a little SAG. I can't get a whole pile in there, so we got to be even more creative and put other things in there, intact oats, whatever. It's a lot of work. And also, though, what we are very good at is making it all the way resistant. So we can take starches, bases, flours, we can steep them, heat treat them, whatever, roast them like the lentils, but you'll produce some RS in there too, which that will lower the glycemic response, but not the glycemic index. So that's why it makes a difference whether it's available or unavailable. So we're pretty good at making the resistant starch or resistant carbohydrate or fiber or whatever you want to call it, the stuff that's still there after 2 hours. But we have a hard time making the SAG. So in the terms of making all those foods I showed you, you need flour and sugar to make these foods, or you don't have those foods. So for sugars, there's only one on the market, platinose. It's slowly digested because of the structure of it, and Stefan can tell me more about why that. But it is completely digested, but slowly digested. But it's the only one I know. I mean, I wish I had it, but Beneo has it. So other offerings, we are trying to produce other carbohydrate offerings. There are some oligosaccharides, like IMOs. They have some resistant parts, but it's mostly digestible and mostly rapid. There are some other oligosaccharides that have some sugars in them, but mostly they're reducing glycemic responses because of the fructose that's in there. And then there's some sugars with non-digestible bonds, but again, those are resistant carbohydrates now, if they're resistant to digestion, so they don't lower GI. So starches, as I said, I work a lot on starches, but also some of the oligosaccharides. There are very few flours that you can get very much SAG in. Par baking, well, yes, but that has limited applications. There's only so many things you can par bake, and you can't infringe someone else's patent. Whole grain flours, yes, have some SAG, but also a lot of the resistant. So then you got to subtract that out. So a flour is, not just all or nothing. It's a combination. It's degrees of digestibility. And starches in general have very diverse digestion profiles. They vary in their RS, the RAG, but they don't have a lot of SAG. And it's hard to push out that part of the digestibility. So in conclusions, we need to try to find SAG sources in order to have a true low glycemic index. Ingredient suppliers like me are working with all the consumer goods companies, trying to find technical solutions to keep producing the products that people want to buy. In terms of understanding how this affects formulation, the glycemic index per se gives us barriers because of the, based on digestible portion. So it's difficult to achieve. Hey, go back. Once you're done, you're done.
Time's up.
Oh, don't. I was just getting to the punchline, building you up, and then.
Try not to.
Hang on. No, you can't clap yet. And also, I heard Tom talk about actually measuring the GR, and yes, there's probably even more imprecision in measuring the GR than there is in the GI, but it is relevant to how consumers eat it. Oh, good, I got back. So I'm not advocating one approach or another. I'm just saying when we're trying to use certain concepts, we have to understand what they mean and how to apply them. As a food manufacturer, we understand that the onus is on us to show that it does produce the glycemic effect that we expect and that consumers expect to have when they eat the product. So should we have multiple approaches? Is there room for both? And I would say, well, not just both, GI, GR, PPG, whatever concepts there are. Scientifically, yes, but I understand the regulatory hurdles. Working with regulatory agency, you need a method, has to be accepted, has to be consistent. So it's not that easy to just say there's going to be one approach and it's going to cover everything. So I hope that was informative, and thank you.
I think that was a really useful presentation, but it's obviously given from your perspective as a representative of a food ingredient company. And so you want to sell something that's magic that you can sprinkle in the food or incorporate.
No, we don't want to sell magic, actually.
No?
No.
Well, why can't you start with plant breeding, conventional plant breeding?
We do, and we have a patent on our Hylon 7, which is high amylose maize.
Yes.
So that's one product we have a patent on. It's not that easy to just all of a sudden breed something new and get a patent. So that's a whole course of action. We have a whole division of plants genetics. We are continually looking for new hybrids, yes.
Well,
but we can't use GMO.
Yeah, that sounds terrific because in Australia the two examples that we have of development have come from, one is CSIRO's Barley Max, which has higher proportions of slowly digested starch, residual starch, and fiber. And I tell you what, when you eat it, you know it. You know that you're feeling fuller for longer. And the other product that I think we'll hear about later is the low GI potato. So just conventional breeding, just looking for which ones have got a low GI.
Those are just like a drop in the bucket. It's a start. That's what we've tried. You know, Hylon 7 has been around for quite a while. The patent expires in a year or two. But in the food industry, I think it's also important to understand is that we can only practice the patents we own. So we can't just suddenly start using somebody else's patented technology. We're all looking for ways to create products, but there's a lot of patents already existing. So we can't just suddenly start using something that's already owned by someone. And that's just the reality. It's frustrating to me because I can see approaches we'd like to try, but we can't. We're not free to try them.
What about from a processing point of view?
Oh yeah, we have very good expertise. We process, and we do these experiments where we take different bases, including like sorghum and things you've never thought of, and we put them through all sorts of different types of processing to try to reduce for whatever functional benefit we're trying to get. If it's nutritional, it's mostly glycemic because we're talking about starches. But we also do textural benefits and all sorts of other types of applications. So yes, we do a lot of that. Consumers don't want chemically modified though. We can produce, we can do it. We can do all sorts of things with technology, but we're also trying to keep it within a natural space. So it's tough to get there.
Well, say I'm a breakfast cereal manufacturer, and I know that most of my breakfast cereals are high GI, but if I look back at my processing procedure and I say, okay, I'm going to, well, for example, I'm going to produce something in cute little shapes and sizes, but I'm not going to do it by puffing and popping. I'm going to do it by conventional pasta making type of operations.
Well, that's fine, but you're going to lose all of your customers that want your puffy loops. You know, there's a whole bunch of people that are going to buy extruded cereals, and they won't just all go to pressed flakes. Or I love muesli, but how many people eat raw muesli in the United States, right? So there's an awful lot of extruded cereals, and extrusion, you know, destroys the resistance and the slowly makes it all pretty high glycemic. So, but that part of the market's still going to be there. But is there something we could do to that where they could still have their puffs and eat it too? You know, that's just the reality of the consumer goods companies. They can't just all of a sudden drop all of those lines of products and make only kibbles and bits. You know, they just can't. They're just, yeah. There's iconic brands too, which I learned being in the food industry. You know, they're iconic brands. People lived on Fruit Loops. They don't want them changed. You know, you touch their Fruit Loops, they're gonna, you know, and Kathy probably laughing over there because General Mills has a lot of iconic brands. Kellogg's has iconic brands. They can't just change them overnight.